intervals, inequalities, and graphs of numerical sets. Okay, so we're going to start off with intervals. I'm sure most of you have seen intervals before in other classes. Every time I teach this class, I am surprised by the number of students who go weeks without mastering this. It's pretty straightforward, and it is the most common way that we are going to be expressing some of our solutions to more advanced problems in this class. So let's do a thorough review of this really quick, and please make sure that you are able to express some of your answers this way and are able to read this notation. The first kind of interval, so types of intervals and their counterparts. So the first type of interval is what's called the open interval. And this is sometimes confused by students with ordered pairs. This is the open interval A to B using parentheses. This is the interval notation. The corresponding inequality notation would be the set of X that is less than B but greater than A, somewhere between A and B. Or as set builder notation, the set builder notation would be the set X such that A is less than X is less than B. Oh, we should have a good talk early on about this. Sorry, it's kind of slipped my mind. How many of you are drawing these squirrely braces here and it's a train wreck? Yeah, I mean, draw one. Here's my insight on this. This is an S, and that's a 2. And if you do it in 2 separate strokes, you can do the other side as a 2, then an S. And then pretty soon, it starts to become one fluid movement. And so maybe that'll help some of you that are having a hard time with your squirrely braces. Does it look any better? Because I see a lot of them that look like this. Things like that. And that's okay. But anyway, there's just some little insight to that kind of thing. S and 2, 2 and S. Give it a shot. Yeah? Elizabeth, I will try to go slower, but that's why we're recording this kind of thing so that you can go back and look at it when you have time. Let's see. Then as far as the graph on the number line is concerned, if this is the number line and this is negative infinity and this is positive infinity, then what we're talking about is A is over here, B is over here. And traditionally, people would use an open dot at A and B to indicate that we're not using the values A and B. And then a horizontal line connecting those two, indicating that we want all points between A and B, but not actually equal to A and B. So it's the corresponding graph. Although sometimes people do it like this, depending upon the book, they'll actually use the round brackets, and sometimes they'll express it that way. Either way is fine. I'll know what you mean as long as you understand what I mean. So both of those would be acceptable, although I'm an open dot kind of guy. But I guess the idea is this corresponds directly to the notation on the interval as well. Yeah? Okay. The next type of interval. So open interval, I should say in a more advanced way, does not contain the boundary. And the boundary is here A and B. That's the bounds, the endpoints. In one dimension, left and right, that's just the endpoints, although the boundary is a little bit more complicated in higher dimensions. Okay. The closed interval is not typically mistaken with an ordered pair because this one uses brackets. So these are parentheses, and these are brackets. These are called braces. So sometimes people say round brackets, square brackets, and squirrely brackets, but they're parentheses, brackets, and braces. Anyway, as far as the inequality notation goes, this is still between A and B, but now we're using inequalities that have equal signs on them. This is A less than or equal to X, less than or equal to B. And this graph is also similar. The only difference here being that we're going to use closed dots or solid dots. That would be the corresponding graph where you might see something like this. There's a couple of different flavors, either closed at A, open at B, or open at A, closed at B. This would be A less than or equal to X, less than or equal to B, and then we would have a closed dot at A, an open dot at B. And then underneath here, parentheses A, comma, B, bracket would be A less than X, less than or equal to B, which would be flip-flopped in terms of which boundary we include. So in the top one here, we include the left boundary, but not the right boundary. And in the bottom one, we include the right boundary, but not the left boundary. So this is a combination of open and closed, which is why it's called mixed. The last two that I want to talk about, or I guess I should say three, are what are called unbounded intervals. And there's a few different versions of this. If you've never seen that symbol before, that's the symbol for infinity, which means unbounded. It's not a location. You cannot arrive there. It just means that the numbers are getting larger and larger and larger. Another version of this might be closed at A, but we never use a square bracket with infinity. Oops, let me move that. We never use a square bracket with infinity because that would mean that we're equal to infinity, and that's nonsense. So watch out for your nonsense. Okay. As far as the intervals go, this is a little bit different. This is just X is any number bigger than A. This is X is any number greater than or equal to A. And if we have a number line over here, negative infinity, positive infinity, and A is on here somewhere, then this one would be an open dot and a ray or an arrow that continues to the right. We put a little arrowhead on there to indicate that it goes in that direction forever. And the other one would be similar, but it would use a closed dot and look like this. Of course, this can go the other direction. We can have negative infinity up to B. We can also have negative infinity up to and including B. This would be X is less than B, and this is X is less than or equal to B. And again, as far as the number line goes, pretty similar stuff here. Let me change the color though. This would be an open dot and an arrow pointing to the left to indicate that we're using any number less than b, versus the solid dot at b, and an arrow to the left. So those are the two different, well, 4 different unbounded intervals. There's one more, I guess. This is the interval negative infinity to infinity. It includes every number ever, and we don't typically write that in interval notation. So this is, or sorry, the inequality. And then the graph, we would write something like this. X is an element of the real numbers. Any element of the real numbers using some of the notation that we talked about above. And then as far as the graph is concerned, that would be just, well, that would be kind of silly. But let's get silly. I don't know. I guess something like this. We don't typically graph that one. There it is. It's every number ever. That's real. So those are intervals. We're going to be using those quite a bit. Make sure you're on top of that. Let's see. What else here? Okay. So do I have an example for that? Okay. Let's do an example. Example 2, did I enumerate this first example? I don't think that I did. This was example 1. Example 2, write using interval notation and graph on the number line. And we have the set x such that x is less than 3 or x is greater than or equal to 2. Now, this is easy enough to graph. Let's start with the graph here. Here's negative infinity. Here's positive infinity. And oops, I'm sorry. X is less than negative 3. That should be a negative 3. My bad. So over here on the left somewhere is negative 3. Over here on the right is 2. You'll notice that I didn't start at 0. First of all, when I draw my number line, I didn't do this. And a lot of people do this kind of thing. They go 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And they're all weirdly spaced. Negative 1, negative 2, blah, blah, blah. And that's super busy. It's hard to look at. They're not evenly spaced. It would be best when you draw your number lines if you only put the numbers on the number line that you're actually using in the problem. There's no need for you to put every single number ever on the number line. It will get crowded. You'll also notice that I didn't even put 0 on here because 0 is not one of the numbers that is one of my boundaries. And if I put 0 on there, people typically get a little bit confused and think for some reason 0 is important to the problem. Now, from this first inequality, x is less than negative 3, I know that that is open because it's not equal to 3, and it's less than, so it's an arrow to the left. For my second inequality, x is greater than or equal to 2, that is a solid dot at 2, but that's an arrow to the right. And this is what's called a broken interval, because it's actually 2 different intervals together. So this first interval is negative infinity up to negative 3, but not including 3. And the second interval includes 2 and then is all numbers greater than 2. So this is the interval negative infinity to negative 3 together with 2 to infinity. And what we do to join these two is we use what's called a union symbol, which is just a little horseshoe-shaped U here. This is the union. It's our way of adjoining these two. And so this is the interval notation for a broken interval. And this is how we join two intervals together.